Okay, here we are back again with example number 2, another long division one. So we need to check the degree of our numerator and the degree of our denominator. The degree of our numerator is more in this case than the degree of our denominator, so we need to do long division. So let's start off with that long division again. Make sure we put in any placeholders. I'm going to need more room. Move myself up here. So we've got 16x squared plus 0x plus 49. And under here we are going to put 16x cubed minus 64x squared and plus 52x. Does not look like we need any placeholders in there. Okay, so first thing that we need to do is ask ourselves, what do we need to multiply to 16x squared to get 16x cubed? And that's going to be just an x. So x times 16x squared is 16x cubed. Then go ahead and multiply all the way through. So plus 0x squared and then plus 49x. Draw your line. Change your signs. These cancel, which is exactly what we wanted. Then negative 64x squared. And this is 52x minus 49x, so that's going to be a plus 3x. Okay, so now what do we multiply to 16 to get negative 64? And what's that going to be? 4, negative 4. So a minus 4 here. So negative 4 times 16 is going to be negative 64 x squared plus 0x. Oh, I forgot to bring down my 194. So bring down the minus 194, and then negative 4 times 49. What's that going to be? Negative 200 minus 4, so negative 196. So draw our line here and change our signs. I just want to double check that one, make sure I'm right on that one. So 4 times 4. Yep, good. So those cancel, and then we have 3x, and then here that's going to be a plus 2. So 3x plus 2 will be our remainder, and so our final answer, complete final answer, is going to be x minus 4 plus 3x plus 2 over 16x squared plus 49. Okay, so this solution over here is what we need to find the integral of. Okay, just a second. Where's her? Okay. Alright, so on this one, since we have a denominator that cannot be factored, so this quadratic equation, but we cannot factor it, so therefore we can't use partial fractions to break that up any. So I am going to rewrite it. So we have x minus 4 plus 3x over 16x squared plus 49 plus 2 over 16x squared. Oakley, can you take that somewhere else, please? 16x squared plus 49. Or mute it or something. Alright, so now we can go ahead and factor or integrate all of this. So in this one, we had to use long division, but we did not need to use partial fractions to go through all of that. So now let's just talk about each individual term. So this first term right here, we can integrate that, no problems. Normal integration on the minus 4 for this fourth term. So I'm really going to treat each one of these like a separate integration problem. For this third term right here, this one I'm going to use u substitution for. Okay, so we'll just take the 16x squared plus 49, set it equal to u, and then du will equal 32x. Of course, we'll have to do something with the 32, but then that x dx will turn into the du there. And so you'll be integrating 1 over u plus whatever you get out in front for your constants. And then here for the very last term, now this one we don't have an extra x in the top, so this is going to be the one where your arctangent comes into play, and you're going to need to know what your a is, and you're going to need to know what your u is. Okay? Alright, so we need to integrate x, and let's just go ahead and set each one of these as a separate integral. So x dx minus the integral of 4 dx plus the integral of 3x over 16x squared plus 49 plus the integral of 2 over 16x squared plus 49. 49 dx. Oh, I forgot a dx on this one. Okay, so I'm going to put my answer down here. So I'm going to just try to keep everything in one place so that I can keep track of what I've done and what I haven't. So I can go ahead and integrate this one. So the integral of the first term is going to be 1/2 x squared minus the integral of the second term, which is going to be 4x. My third term, now this is the one that we're going to have to do u substitution. So let's say that u equals 16x squared plus 49, and then du equals 32x dx. Okay, I don't have anywhere for that 32 to go, so I'm going to go out front. 1 over 32 du is what we're going to substitute for x dx. So that leaves my 3 out in front also. So I'll have a 3 over 32 out in front times the integral of du over u. Whoops, that's not a u. U. Okay, so for that one, we're going to have 3 over 32 times the natural log of the absolute value of u, which u was 16x squared plus 49. Okay, so then that will be our third term. (16x squared plus 49). Okay, now we're ready for our last term. I'm going to get myself some space here again. So I'm going to erase this real quick. Okay, now I am going to do a u substitution on this one as well. And make sure that you have your arctangent, your blue sheet out in front of you there so you can see exactly how we set up that arctangent one. I am going to rewrite it like it is there. So I'm going to pull out that last integral right there. Let's pull the 2 out in front. On this one, u, all of that, so let's just rewrite it. So we have dx over, and they have theirs written backwards, so I'm going to go ahead and write it that way. So 7 squared, in the family room with Oakley, 7 squared plus 4x, and then all of that squared. Okay, so hopefully that will be a little easier when we follow through on the arctangent. So it's going to equal 2 times 1 over a, which a is 7, times the arctangent of u, which is 4x, over a, which was 7. Okay, so that's the last part here. Ooh, hopefully I can fit that in here. So plus 2/7. I'm going to shorten that arctan. And then 4x over 7. And then plus c. C. Okay, so that is my complete answer for that one. My best advice for these is just to take your integral one step at a time. Have a place to write out your answer because you kind of tend to need more steps for some of them than you do others. When I did my written example, I really just kept bringing down, I did a lot of writing. You really don't have to do that much writing to keep everything at the same step. You can make yourself a place for your answer and then just go from there. So hopefully that helps for example number 2. One more example we're going to go through before the end of our notes. Okay, I gotta go back to this one. I forgot my U substitution. Well, I thought about it, but then I didn't think it mattered, but it does matter, so I had to come back and correct my mistake here. So on this one, we do have to count this as U substitution. So we say 4x is equal to U. Therefore, our du is going to be equal to 4 dx. We do not have to have a 4 to substitute that in with. So we're going to do 1/4 du is going to replace our dx. So what that means is we would have had a 1/4 out here in front of here. So we would have had a 2/4 and a 2/4 here. So then that cancels to 1/2, and then we end up with 1/14 as our value in front of there. So I'm going to come over here and erase my answer right here. Okay, so sorry about that. But we will put a 1/4. Why does it do that to me? All right, we'll put a 1/4 in here, 1/14 in here. Okay, there we go. And now we've got the correct answer. All right, on example number 3, let's go ahead and factor out our denominator. So we can pull out an x, and then we would have x squared plus 3 left. So when we go to do our partial fractions on this one, we're going to have a over x, and then plus bx plus c over x squared plus 3. So now we can rewrite that, multiplying both sides by the least common denominator, so that we don't have any fractions left. We're going to have ax squared plus 3x, because the x's will cancel for this first term. Those x's will cancel. So we'll multiply through what was in the parentheses. Then on this next part, our x squared plus 3's will cancel, and we'll be left with just x in the numerator. So bx squared plus cx. Now, combining like terms, we can factor out an x squared, and our coefficient would be a plus b, x squared plus, oh, that's not supposed to be, I did this last time too, didn't I? That is supposed to be a 3a. And then, so just a c for our coefficient for x, and then a 3a for our coefficient for the constants. So now, using our coefficients for our constants, we have a plus b equals 1, c equals -1, and 3a equals 6. So now we can go ahead and start solving for each one of those. So a is equal to 2, c is equal to -1, and 2 plus b equals 1, therefore b also equals -1. So what we end up needing to integrate is the integral of 2 over x, and let's separate all of these out, dx, plus the integral of -1x minus 1 over x squared plus 3. Now this one, we can split this up into 2 separate integrals as well. So let's split that fraction. So we have the integral of 2 over x dx plus the integral of -1 over 1x over x squared plus 3, and then plus the integral of -1 over x squared plus 3 dx. So again, on this one, it's going to end up being just the same. I'm going to run out of time on this video. It's going to be just the same as the last one, pretty much. This one is going to be a natural log, so 2 natural log of x. This one, you'll need to do U substitution. This one will nicely show up. You do need to make a square root of 3 squared on that one. Then use the arctangent, and then that'll work it for that one. So just make sure you've got that as the square root of 3 squared. So the square root of 3 is going to be a. U is going to equal to just x. So you will not have to worry about your chain rule on this one like the mistake I made on the last example. You won't have that mistake on this one because you don't need it. This one, the U substitution should work out really good.